Oh my gosh, guys, this is so embarrassing. You'll never believe what just happened. So I'm sitting in my bed doing these videos, and I ate all my chili, so I wanted some more, but I can't walk, so I called my mom to ask her if she would bring me the chili, and I can hear her and my roommate talking downstairs, and my roommate point blank told her that he thinks her phone is ringing, and it was me calling her, and she didn't pick it up. So that's pretty low for me. But let's go ahead and answer these questions. Just like the last one, except this time we are getting our information from a data table instead of from a graph. But a data table and a graph are different ways of representing the same information, as is a function. A function is another way of representing that same information, just different modes of interpreting it, and different pros and cons of each. So let's look at A. A is asking us to find 2 of f of g of 1. Is that you? Can I have some more chili?
Yeah, just in time. We're going to go for a walk, and I didn't want to interrupt you because you were...
Perfect, thanks. Just so you know, your videos, your voice is going to be on the internet now.
Oh.
I just told her she's going to be on the internet, and she freaked out. So, anyways, let's use this data table. So we are trying to find 2 of f of g of 1. So that's like saying, hey, find me f of g of 1 and then multiply it by 2. So we can do that. And I don't know why I just undid all that, but there, I can bring it back because I'm powerful. So g of 1, again, we're doing our innermost function first. G of 1 says 1 is the x value on g, so what's the y value? Well, go to where the x value is -1 and find the y value on your g function. Again, these are y values. F of x and g of x are fancy ways of saying y. So g of 1 is -1. So now we need to find what is f of -1. Again, we're using the output of g of 1 as our input in f. So f of -1, notice it doesn't say f inverse, it says f of -1, says go to the x value of -1 and tell me the whoa, wait, oh yeah, okay, I'm good. I thought I used the wrong function last time, but then I remember it was f and g. So we go to -1 and we go to our f value, which is 6. So f of -1 is 6. So all together now, 2 times f of g of 1 is going to be 2 times 6, which is 12. So that should be 12 right there. And let's see how much of this I can... Oh, wait. Oh, no, I can't do that. Let's do part B now. Same idea, no compositions this time. Just got to figure out what all that jazz is. So let's do g of 3 first. Well, g of 3 says go to the x value of 3 and tell me what the function g is doing. Well, g is hanging out as the number -2. That's a 2 right there. I promise you that's a 2. So g of 3 is -2. And that's being multiplied by f of 0, and f of 0 is -1. So I'm just going to simplify that already. -2 times -1 is +2. And then we are subtracting f of -2. F of -2 says go to the x value of -2. Go to your f function. It is 5. So really we're dealing with 2 minus 5, which is -3. Chili has been delivered, so I'm going to pause. Just kidding, it's insanely hot. The hot pad was a dead giveaway, but I didn't see it until after I touched the bowl. So let's do another problem. F inverse of 5 times g inverse of -2. Okay, these are a little more interesting. So again, think about what I've said a bunch of times so far in these videos. This is function notation. In function notation, you put an x value in the parentheses. So this 5 is an x value, but it's an x value on the inverse function, which means when we are talking about the function, it is a y value on the function. So 5 is a y value on our f function, the original function, and we need to find the corresponding x value. So this is actually double helpful, because remember those problems where you had to like graph things and then intersect things with lines? That's what that notation looked like. F of x equals 5, or f inverse of x equals 5, stuff like that. But, you know, get used to this stuff. That's what it looks like. So let's answer that question. Let's go to our f function. Let's find where the y value, remember that's a y value, is equal to 5, and let's use the corresponding x value. So f of 5 is actually negative 2. And we're going to do the same thing with g inverse of negative 2. We're going to find the y value on g that's equal to negative 2, which is right there, and we're going to use the corresponding x value, which is 3. So that's going to give us negative 6. So let's erase some of this stuff so we can do the last one. The last one says, whoa, it's a composition of inverses. Why would you do that to us, Mr. Reed? Because you just do it. It ain't no thing. So g inverse of negative 1 says, go to the value, go to the spot on the thing where that happens. So let's go to the g of x value of negative 1. Negative 1 happens right there at an x value of 1. So g inverse of negative 1 is 1. So now I need to find f inverse of 1. So find where f is equal to 1. F is equal to 1 when x is equal to 3. So f inverse of 1 equals 3.